everybody, we're going to go through a quick review of scientific notation. I know you've done this before, most recently in chemistry, so you should be pretty familiar with this. Let's look at a number here, the mass of Jupiter. It's a really big number, a lot of digits there, really inconvenient to write it all out like that. Similar, we've got the mass of an electron. Now, we have a similar problem here, a lot of digits. Now, it's a very small value, but a lot of digits past that decimal point. So scientific notation you're going to use for either really big numbers or really small numbers. And they don't have to be masses. I just picked two masses in this case. They could be distances or whatever, just any two or any really big number or really small number. Okay, so the general form scientific notation, m times 10 to the n power, where m is a number greater than or equal to 1 but less than 10. So you could have 1.000 all the way up to 9.99999. Basically, you're going to have a single digit and then any decimal places after that. N is an integer, so it's basically a whole number, but it can be positive or negative. So let's look at those numbers again. We have the mass of Jupiter. Now, usually when you're writing a lot of digits, you separate them in groups of 3 with either a comma, or in this case, I'm using a space. Now, let's count how many decimal places we have to move. So this is where we want our decimal point. We want a single digit and then the decimal. So we're going to go over 3, 6, 9, 12, 15, 18, 21, 24, 27. So in order to move that decimal place over there, if we have 1.898, we have to multiply that by 10 to the 27 to get our big number. So there we have the number in scientific notation. Similar with the electron, again, a lot of digits there, very inconvenient. Let's put them in groups of 3. Okay, now we want our decimal point right here. Okay, well, since I grouped the 3 starting at my original decimal point, I'm going to start here and count over. Okay, so we've got 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, and then one more. So we've got 31 places we have to move our decimal point. Now this is a very small number, so we're going to have 10 to the negative 31 on that. So the mass of an electron, 9.11 times 10 to the negative 31. And that's scientific notation. Okay, so we've got those numbers in scientific notation, but could we write it as 1,898 times 10 to the 24 kilograms? That is the same thing. To get from 1.898 to 1898, we have to multiply by 1,000. So this one we'd have to divide by 1,000 so we don't change the overall number. Or the electron, could we have 91.1 times 10 to the negative 32? Well, what we did to our base number here is we multiplied by 10. So the exponent here, we have to divide that by 10 to keep it equivalent. Can we do that? Is that okay? Well, both of those numbers are fine. Okay, so for this class, any of those answers would be acceptable. But note that, our new numbers here, these two, are not proper scientific notation, but that's totally fine for our class if you express a number that way. Okay, let's try a calculation. All right, so let's have this division problem. 2.47 times 10 to the negative 12 divided by 1.94 times 10 to the negative 7. I want you to take your calculator out and try this one. So pause the video right here, give it a shot, and we'll come back and see if you got it. Okay, let's see what you got. The correct answer is 1.273 times 10 to the negative 5. Okay, that is the correct answer. If you got that, you're probably in good shape with scientific notation and calculating. If not, let's take a look at this. So a common mistake is some students will just type it in their calculator just as it's written. What your calculator does is it follows order of operations. So it will take the 2.47. Now when you have the 10 to the whatever like that, it does obey that, or it does see that as a single number. So 2.47 times 10 to the negative 12, and then your calculator divides by 1.94, and then it will take that whole number times 10 to the negative 7. Well, you don't want that. You want 10 to the negative 7 in the denominator. So your calculator is not doing anything wrong. It's doing what you're telling it to do. It's just following order of operations. So one way around that is to put parentheses around both numbers. You've got this number in parentheses divided by that number in parentheses. Okay? And that'll work. It's a lot of keystrokes. It's a lot of just keeping track of things and making sure you have parentheses in the right places. So the preferred method is using that EE button. If you've never used it, you should try it out. So the EE button is, well, it's right here. So you have to use the second button. So second comma gives you the EE. And as you can see on the display there, that E, and then when you do the EE, it just shows up as a single E, as you can see on the display on the left. But that takes the place of times 10 to the, and then you just type in the power there. It's that easy, okay? So let me walk you through real quickly how to punch this in the calculator. Okay, so we're just going to enter our first number, 2.47, and like I said, instead of doing the times 10 to the, we'll just go second comma to get that E in there, and then negative 12. So by using that EE button, the calculator sees this entire thing as a single number, and then divided by our other number, 1.94, and then I'll do the EE again, negative 7. So again, it sees one number divided by another number. You don't have to worry about order of operations. You're going to get the right answer every time. So try that out. I hope it helps.